Okay, welcome to the third part video of installing the C3Dt the Cantilever printer as seen on Instructables.com. Link below. That said, this entire video can be taken separate from the whole C3Dt printer because what we're doing in this video is we're setting up the wiring of the KFB 2.0 board. So even if you're printing, or it doesn't matter what kind of printer you're making, the wiring will apply to any type of printer here. We will be connecting, we'll be setting up the stepper drivers, and we're going to be using these standard A9844 stepper drivers. We're using 4 stepper motors, X, Y, Z, and the extruder. We're using the discount LCD, MakerBot end stops. We have a 5-volt cooling fan that we're going to use to cool the heatsink on the hot end. I have a 12-volt little turbo fan that we will be using for the parts cooling on this printer. We'll be setting up this printer with an inductive sensor, so we'll go into that, and I might separate that as a separate video because we'll be doing the actual wiring, which involves some additional soldering work and resistors to actually get this to work on the KFB board. We're using a hot end, so from the hot end we're going to be dealing with heating up the hot end and reading the thermistor. That'll be part of it, and then we'll be hooking up a silicon hotbed. We'll be providing power to the hotbed, 12 volts, and we have the thermistor readings coming out. That's all that we will be hooking up in this video. And again, this video can stand all by itself regardless of what printer you're building. You might ask, why am I hooking up all of this stuff before I've actually put my printer together? I kind of like to know if stuff works before I put things together. So my goal is to make a good looking printer, so I will be sleeving all my wires, and the last thing that I want to happen is that I've sleeved all my wires and then find out that this stepper doesn't work. And I have to say that these steppers right now, these are all used steppers. I'm not even sure if they will work, so this will be a good test to see if all the components work. I will be installing Marlin on this board, and I will be using the setup for the C3Dt/C printer, which is the cantilever printer. But again, that could be any printer that you would like to test. First things first, specifically to the C3Dt/C printer, I need to kind of look at the wire lengths because I will be dealing with a cantilever design where the Z motor will be fairly close to the board, the Y motor will be at a fixed distance of the board. The X motor, however, which will be going up and down with the Z axis, will be variable, so we need to have the right length of wire that. And then last but not least, all the wires that come from the hot end, which means heating the hot end, the thermistor, the wires going to the inductive sensor, 2 wires going to the cooling fan, and 2 wires going to the hot end fan. All of those need to be long enough to be able to travel up and down and left and right on the printer. I will be cutting my wires and soldering them to length where I actually have to extend them, and I will fast forward through that. I'm actually not going to cut the wires to the motors yet because at this point I don't even know if they work. I'll hold off on that, but I will be extending all the wires to the proper length before I hook them up. Okay, so I'm going to start with the end stop wires first. Make sure that these are wired properly. They go in like this. You can check on the back of the board. Power comes in closest to the processor, ground, and then signals. Power, ground, signal. And the Z min is what we're looking for. So that one will go here. All right. X-Men. Now remember, we're using the inductive for the Z axis. All right. That's the wiring for the end stops. Then we are going to work on the wiring for hot end and the thermistor wire. Put that aside. Next up are the fan wires. So we have the 12-volt turbo fan, and we have the 5-volt hot end fan. Now the interesting thing about this one, this was given to me in a trade for my old printer. This has 4 wires. It's a PWM, but you'll find that most boards, even the PWM outputs, basically means it's like only have 2 wires. Luckily, this fan, which is a Noctua, and you can't go wrong with a Noctua fan, they're super silent. It came with a little adapter, that's this one, so that tells me that based on this adapter, the black and yellow are the wires. So black would be ground, and yellow would be the 5-volt input, and then we can just ignore the green and the blue wire, which are signal wires. So that looks all right. All right, that's one fan. Next fan is this one. Now, the thing with the motors is they use these 4-prong connectors, and I'm going to leave them on because I want to make sure not each board is created equal. The pairs that are in the motor don't always line up between different printers. I might have to rearrange this. I'm going to test them out as is. If they work, then good. I will cut them and recrimp them at the right length. If not, I'm going to have to figure out the proper pairing and how that relates to the actual board. Okay, so we're back to the board. I have all the wires in place. Before we do anything with the board, let's prepare the board itself to actually have the stepper controllers or the stepper drivers installed. These are the A4988 drivers. They are about $9 on Amazon, and you can't really go wrong. These can burn out, but they're so cheap to replace. You can't really go wrong with these little things, and they work just fine. Before the stepper drivers go on, when you buy these drivers or when you buy a board, they generally come with these little jumpers. They go on the jumpers in between the drivers, and this is to set the microstepping to 16. He's going to add these. These are, by the way, not needed if you use the TMC drivers. These wires basically are not connected, so it makes no difference if you put the jumpers in or not. But for the A4988 drivers, we do need to add the jumpers to the board. Okay, so we have the jumpers in place. Now, very important, when you add these chips, you need to add them in the right way. You can follow my lead, but what you really should be looking at is if you look at the bottom of these drivers, it tells you a number of things, so direction and ground, and that's basically what all you need to line up the chips here. But so direction and ground, if we look at that, and we look at the back of the board here, we have at the bottom towards the processor, we have the direction and ground. That's where this needs to point. Direction and ground needs to point downwards. All right, and we're going to push these in. I'm not going to put the heat sinks on yet. I'm not even sure if I'm going to put them all together because this printer won't be running very hot, but it also will be blowing air through. But generally these come with the little heat sinks that theoretically don't do much because most heat dissipation from these chips actually is towards the bottom. But so I don't know if they just do it because it looks cool, but it is what it is. But so most printers you'll see they'll put the heat sinks on top here. The scary thing is that like it has this like glue underneath here, but it slides, so it's easy to actually short these wires when you get too close with the heatsink to these pins that are on the side. But we will add those later on. That's really all you need for preparation of the board. We need to hook up the power, of course. I already, in my previous video, set up the power source, which is this PSU, which has the on-off switch with a fuse in there. And outcoming, we have the 12 volt and ground. Okay, so we are going to quickly crimp these wires. Get it hooked up now. You'll notice I actually cut off a piece of the plastic around the crimping, and I did this on purpose because there's going to be very little room between the board here and the actual case. It's going to be a tight space. Okay. Power input to the KFB 2.0 is this standalone little connector here, and it indicates plus minus. If you look closely, it takes 12 to 24 volts. Right now we're setting this printer up to be running on 12 volt. All right. At this point, I really don't have to do much else than, so I'm gonna, well, actually, let's just keep connecting the wires here. So we have the 24 or the 12 volt Parks cooling fan, which is a little turbine fan that's going to be pointing directly at the filament output. That's actually going to be speed control, like PWM control through the board. And there's a fan output on the board here that you can configure in Marlin to basically use that as your variable fan speed. All right, thing about fans, they are polarity. What is going on here? That's not good. Polarity matters in fans. So red plus, black, ground, or minus. So in this case, we're going to go into the fan controlled output, plus, minus. Again, now we're running space problems here, so I might have to redo this, but right now we're just testing the hardware. Okay, so then we have hot bed, heater, heater 1. And so in this case, we only care about the hot bed and the heater. So if we look at the hot end, okay, so here we have the hot end. And the thermistor. Now, looking closely at this is a knockoff E3D. Many of these you will get wrong temperature readings because when they manufacture these, they tighten this thermistor wire way too tight and actually shorting it with the screw itself, so you get the wrong temperature reading. So if that happens, it might not be your thermistor being bad, but it might just be that you have to kind of loosen this wire, because I've seen this in several of these knockoffs that I bought where I'm getting the wrong temperature reading. I have to crimp these as well. All right, and we're going to go with the temp output. So we have temp 0, temp 1, and temp bed. So that would be temp 0 is for extruder or hot end 1, and then temp bed is for the bed itself. Polarity does not matter for the thermistors. It doesn't matter which order you connect them in. Temp 0 goes in here. The hot end wires themselves go in heater 0. The hot end, again, is not really polarity sensitive either. Alright, so at this point we have power in, we have power to the hot end, we have power to the controllable fan, we have the temperature, the thermistor connected to the board. Alright, we're going to hook up the 5-volt fan, which is just a matter of plugging it into the always on 5-volt here. And then we can also hook up the LCD. But when you buy an LCD like this, generally they come with these ribbon wires. Important, so they have like a little indentation here, so you know how to plug them in. They should only fit in one way. Okay, and then we go from, if you look on the board, on the display itself here, there's EXP2 and EXP1, and that should correspond to EXP1 and EXP2. So that should be fairly easy. Alright, next for the LCD, we can hook up the end stops. I might have fast forwarded through it in the wiring, but so it's very important. These MakerBots, that's the power, ground, and signal. And they have to correspond to that on the board with power, ground, and signal. If you connect these the wrong way around, it's my understanding, and it's happened to me though, that you will actually be sending current right through the board where it's not supposed to go. So make sure you get this right. In the case of the KFB here, the actual power, the VCC, is towards the processor, and that's how I wired them. So we're going to connect the Y end stop, and we will connect the X, and we're going to put them in the both in the min. We don't use the max outputs, at least not in this configuration. Alright, so at this point we have everything hooked up but the induction sensor, and I'm going to hold off. Oh, sorry, no, forgot one step. We haven't hooked up the bed yet. I'm using one of these for the bed. They come in different, this is the silicon bed that came in a kit. Some of you have like the metal aluminum beds. It's all the same. There's no polarity on these beds. The thermistor, same thing. There's no polarity either. These kind of have the nice silicon wire, which is good because this bed will be moving back and forth in the printer, so these wires are proper for this design. So that's the bed temperature that goes in here, and then finally hotbed are these two here. So we're going to connect to hotbed. Polarity doesn't matter. All right, so it's a giant mess on the table here. But that's okay. So we have everything hooked up. 5-volt fan, bed, hot end, controllable fan, power input from the power source. We have 2 end stops connected yet. We have not done the Z stop yet, which will actually be connected via thermistor, and I'm going to make a separate video on that. And then we've got the LCD hooked up, the BET thermistor, and the hot end thermistor. And we need to hook up the motors. Now, again, what I said earlier in the video, these motors are used, so I'm going to have to figure out if they actually are paired the same way as this board expects them to be. Now that everything has been wired up, and for those of you observant, you might have noticed that earlier I connected the plus and the minus and they were actually reversed, so they are proper now. Plus to plus and minus coming from the 12-volt source. At this point we're ready to start testing, so the first thing we need to do is we need to actually get the Marlin firmware on the KFB 2.0 board. For this implementation, I'm going to use KFB 2.0, or sorry, Marlin 2.0, which is their latest release. So why go, with something later? My earlier prototypes were built on 1.9. 2.0 has a couple of more features. Not that they really matter here, but it's best probably to get on the latest versions. I will hook up the USB cable, connect it to my computer. The good news is two things already work. The 5-volt fan is turning just based on the power coming from the computer, and the LCD is operating too. Not very bright, but that's, it's, right now it's running off of the power off of the actual USB drive. I guess we can switch on the power unit and see what happens, and there you go. So now it's getting the 12 volt from the power unit. The fan kicked in a little harder and the screen is a little brighter. But the good news is always on fan runs, because I was kind of worried. This is a PWM fan with 4 wires, but the 2 wires, the way they are connected, works as expected. The LCD works too, and as you can see, there already is a version of Marlin on this board. I've been, experimenting with this board before, but we'll go through the steps now. Let me resize this guy here. All right, I opened the Marlin 2.0 version, but that's not really what we need right now, because we're not going to do any fancy configurations. So let's see, so if we look at the configuration, I'm not going to change too much. I'm just going to turn on the features that are required for testing the components. So that would be the controller fan. Oh, sorry, before I go, another thing that I found out is that in order to install Marlin 2.0, you need to download the Arduino 1.9 beta version. Apparently, if you don't, you get like a compilation error that I had to deal with earlier, so you don't have to. If we go through the main steps here, there's nothing really of importance here. Show custom screen, no. Serial port, no. Baud rate. This you will need to know if you want to connect to it with prompt interface later on, so we're using the baud rate of 250,000. The board, we select the board, MKS Gen L. You could select the RAMs board, but I'm not sure if that's going to operate the controller fan properly. Extruders, we're only using one extruder. Yeah. All right, the thermal settings. So we are using the 100K thermistor. So we have a sensor for the extruder 1, or hot end 1, which is the temp sensor 0, and we have a thermistor on the BET. So we've got a 1 and a 1 here. So that'd be for the temperature readings. We are using the X, the Y, and the Z min plug for our end stops, even though the Z min plug will actually go to the thermistor, but we're going to turn it on nonetheless. For now, we're going to leave this the same. We might have to do something with this inverting of the end stops, but we'll see that when we turn it on. The types of drivers, this is new in 2.0 or maybe even a 1.9, but we're using the A4988 drivers, so you can just leave these off because it defaults to 84 or 4988 drivers. Beyond that, we're not going to worry about steps per unit yet. That will be when we get to the actual calibration of things. All we need right now is to test if the motors are turning or not. Invert of the directions of the X, Y, and Z. Again, I'm not going to worry about that now. All I care about if they turn, and if we wire them up and it turns out they're turning the wrong way, we can change that through the software here, so I'm not too worried about that. Same thing for extrusion. Right now I'm just going to determine if the motors actually turn or not. The only thing left, I believe, will be for the LCD, and that is we're using the full discount. There's two discount LCDs in here. There's the rep discount, which is this one. The rep discount smart controller is the narrow one that has the, I believe, 6 lines on it. Actually, I have an example here. This is the narrow one. In our case, we're using the full graphics one, so we're going to look again for discount. And here we got the full diff, so it's already turned on. So the full graphics smart controller, and that's pretty much it. Okay, so these are all the settings I really care. Oh, actually, no, let me take that back. The one thing that we can also care about is the controller fan, and that is actually pin related. And unfortunately, or not unfortunately, because right now I cannot see all the pins related boards, because there's a couple of settings that we have to validate for the controller fan pin, which is MOSFET 7, I believe. So let's see if we can just open the text file. So if we look at Marlin, so before and all of the files were all within the same folder and it would show up, so now they've separated the bulk of the code under this subfolder here, and so we are looking at the pins, and we are interested in 2 files with regards to the pins. So the one that we defined in boards is the MKS Gen L, so if we open that one first, and if we look at this, there's not a whole lot in here. What it basically defines the board name, and then it defines the pin 7 here for MOSFET B, which is the actual pin that we're going to be using for the controller. And then the next thing that we see here is that it actually includes the pins RAMs. So the MKS Gen really is nothing more than the RAMs board plus this additional MOSFET pin. Let's open the pins RAMs as well, because we actually have to make a change there, which is a little surprising, but it's alright, this guy here. When you download the software, this value is set to -1, and this should be 7, and once this is set to 7, the controller fan should operate properly. We can now upload the firmware to the board. So let's look, we're on COM 11, I believe that is correct. Let's just upload this to the board. Now it is writing, reading, and if all goes well, when it's done reading, I believe we should see the board reset itself. Yeah, so it switched here back to Marlin and it came back up. Now we have the firmware installed, and see if you can see this, the display is back up, so it reset with the latest firmware. So what I will do next is I will go to Pronterface. Pronterface is the host software that can control many of the features on the 3D printer. I'm going to move CD G codes that we're running. Okay, so I'm going to connect, and remember it was 250,000 baud rate. I'm connecting to the printer online, KFB2.0 X. And the first thing that we can test right now is to see what we're getting when we actually test the end stops. 119, so the G code M119 will give you the current status of the end stops, and as we see right here, they're all triggered. That means that we have to actually go back into the Marlin code and reverse the end stops. Here we go. X min stop inverting Y and Z, so we're going to invert all of these. And we're going to upload this again. Okay, so it reflashed. By the way, remember to disconnect from Pronterface before you try to upload, because Marlin or Arduino cannot upload to the KFB board if the Pronterface is connected. Alright, we're going to switch back to Pronterface, and we're going to connect again. Okay, so we're connected. We're going to send the M119 again. Okay, and so now at this point we see X min, Y min, and Z min are all open. We can now try one of them out. So I will press the one that I see lying here, and I will send M119 again. And we see that at this point Y is triggered. I'm going to release it, send M119 again, and it's open again. I'm going to try the other end stop, which would be the X. Press it, and X shows as triggered. I'm going to release it, send it again, and it's open. So the end stops are working properly. At this point, what we can do is we can do a full home. So I can simply do the full home here with this one, which will first do the X, the Y, and then the Z. Actually, let me put the motors in the picture here so we can actually see something happening. Alright, we are going to now press the home, and I hope to see some motors turning. Alright, there's one, that would be X. Let me press the X home stop. Okay, that registered. That's the Y. I'm going to press the Y. Now the Z should start running. And the Z is not running. So that's not good. Let's try the Z home individually. And it's just not running. Okay, that's unfortunate. Let's test. So let's reset, because now it's just trying to run the motor waiting for a signal from the end stop. So I'm going to reset, disconnect, and connect, and the connection will force a reset. Here we go. So we're resetting again. So the Z axis is not running. I'm going to test the extruder. We can send the G code M302 P1. Okay. Alright, that works. So that overrode the cold prevention, and we can see the extruder motor running. So at this point we have LCDs working properly, we have the end stops working properly. The next thing we can test is the actual controller fan, or sorry, not the controller fan, but the cooling fan, which is controlled with the command M106. and that actually turned on the controller fan. So that's good. That's blowing nicely. The controller fan works too, which is the MOSFET 7. I'll send an M107 to stop it. The only thing not working right now is the Z-axis. So now there's a couple of things we can try, or a couple things that could be going on. I could have a loose connection on the Z-axis. I could have a bad driver on the Z-axis, or I could have a bad motor on the Z-axis. So there's a lot of stuff that could be going on here right now. The first thing I'm going to do is I'm just going to test the voltage that we're getting. So I'm going to put the ground on the ground, and I'm going to put the plus of my voltage meter on the little pot meter screw, and we're getting 0.54 volts. The other one is reading a 611, 637, 640. Now that could be a bit low for all of them because these are 1.5 amp motors, I think. But what I will do is I will try to increase the voltage a little bit on the Z to see if that makes a difference. Turn it clockwise and see what happens. 0.69, so that's higher. These are literally like quarter turns of the screw. Don't go crazy. So voltage has been increased a little bit. I'm going to try that. Change the Z motor again. And we're getting nothing. I'm also feeling no resistance. It's like there's no power. Coming through. Next step, what I'll do is try a different motor. So I'll switch out the motors and see if that makes a difference, and that would indicate that the motor would be a problem. Now, I'm not going to pull out or push in these motors while the power is on, so I'm going to have to turn the power off. I'm even going to disconnect the 5 volts here. All right, and I'm going to switch out Z for the E. Now we know that the E motor runs because we just tested that, so we're just going to flip those over and see if that changes anything. And I gotta say, these motors, I don't think break that often, so I doubt it's the actual motor, but who knows? We'll see. Turn the power back on, plug it back in, and we'll try this again. Test the extruder again. We switched the Z motor to the extruder and the motor's running, so it's clearly not the motor that's the problem. We switched the motors and we're still having the same problem, so that seems to indicate that the driver itself is not working properly. So the next thing that we'll do is we will change out the stepper driver. So again, I'm going to stepper driver with a different one. No guarantee that this one is working, but what are the chances that both of them are broken, right? So okay, so we changed out the stepper driver. Power up again. Connect. And see what happens this time. Connect with interface again. And we're going to do a hold of all the drives. That's on. X. It actually started homing Z first, which it would have failed because there's no end stop connected to, but the motor ran. So the Z motor ran. So let me repeat that process again. I'm going to connect, and what you'll see is that the Z motor is the first to home. Actually, let me just press Z home in this case, and we can see it's homing. But there's no end stop associated with it, so this is just going to keep turning until it runs out and says there's going to be a homing error. All right, not even going to turn off, just keeps turning. Clearly, what we were looking at was a stepper driver issue. Okay, so now we have all the stepper drivers running. I'm not going to worry too much about the order of the homing that's happening right now, because that will all be part of the configuration of the software once we get into the detailed configuration. A couple other things to look at. Clearly what's working is the thermistors. Both are showing the room temperature right now here. They're not completely in sync, but it's close enough as far as these little transistors goes. What we can do is we can actually try to heat up hot end, and I'm just going to heat it up to 50 degrees here. I'm not going to burn through the table or anything. I want to see it heat up, and I want to see it reach go up in temperature. So I'm going to set the heater on. So now down here at heater it shows 20 up to 50. So now it's supposed to heat up to 50. Let's see, there we go, 27, 35. This is good. All I need to know is that it's heating up, so I'm going to turn it off now. At the bed, we're going to try the same thing. We're going to heat it up to 50 degrees. Let's see what happens. 19 out of 50. Here we go at 20, 21, 22, 24. There we go. So the bed is heating up properly too, and the thermistors are ready for use. So this is good. At this point, all electronics except for the inductive sensor, which we still have to do, are operational on this board. That's good. I think what I'll do is I'm gonna conclude this video with wiring of all the components. What I will have to go through now is I will have to actually crimp the proper connectors on these motors, and then the next thing that I will have to do is actually wire up the inductive sensor, which is going to require soldering in some resistors to divert power. I will actually dedicate my next video to that particular piece. I will clean up the wiring or take out whatever is here that I don't need for that test, and then take it to the next step. Thank you. If you liked the video, give me a thumbs up, please. Subscribe. If you really want to help me out, go to my Patreon account and support me. I do all of this for free, and I get nothing in return, but it is costing me a lot of money. And like I said, a lot of the components that we're seeing here right now are all used components that I got in different trades, because I simply don't have the funds right now to buy all new stuff. Help me out if you can. Thank you, and have a good day.